things to remember. First of all, when you see something like this, we've got to get some notation straight first of all. So when you see W of t, that's just the same thing as having y. So y is equal to 2 raised to the t power. So don't get that confused. If you see W of t, that just means we have a function of t. So W means we have a function of t. In the past, you probably saw it, if you've seen it before, written like this. F of x, that just means we have a function of x. Does that make sense, everybody? But it's the same thing as a y, so we can't get that confused. So it says, okay, find W of 1. So notice instead of W of t, we want W of 1. So W of 1 is equal to, we're replacing a 1 wherever there's a t. So that's W of 1 equals 2 to the first. So now guys, W of 1, people try to calculate and that's confusing to them because you're not calculating this piece. It just means what's my function at 1? So 2 to the first power is 2, correct? So our answer is 2. We just evaluated, we plugged in 1 for this function to get 2. So we can't let function notation throw us off, just like a y. Does that make sense, everybody? Okay, let's do another one off your worksheet. Number 2 says, so a couple of things to remember. It's been a while since we've probably seen absolute values back to secondary math 1. So K of A just means we have a function of A, which is equal to the absolute value. Those lines are absolute value symbols. Just a reminder of what absolute value symbols are. It just literally makes everything positive. So if you have a negative in there, it'll make it positive. If you have a positive, it stays positive. All right, so let's plug in. We're doing K of negative 8. So we're replacing negative 8 wherever there's an A. So that's negative 8. So now once again, we're not calculating this piece. That's just like y equals. So we have the absolute value of negative 8 minus 3. Let's simplify that. What is the absolute value of negative 8? Absolute values make it positive. So this is really 8 minus 3, which is 5. Our answer is 5. We evaluated our function at negative 8 and got out 5. Everybody understand? Pretty easy, right? How about number 3? So it says g of n is equal to negative 2n minus 1, g of 7. So now we're finding g of 7. Wherever there's an n, we're putting in a 7. If you're ever if you're replacing it, I suggest strongly a parenthesis. So we'll be putting in a 7 right there. So g of 7 is negative 2 times 7. Negative 2 times 7. Does everybody see where I'm plugging it in? Minus 1. Now don't try to calculate that. That's just y equals. So what's our answer? What's negative 2? Now remember, operations come like, sorry, not function operations. What comes first, multiplication or addition and subtraction? Multiplication, order of operations, that's what I'm looking for. So multiply those two together first, we get negative 14. So we really have negative 14 minus 1, which is negative 15. So our function g at 7 was negative 15. When we plugged in 7, we got out negative 15. Okay, number 4, h of t is equal to t squared plus 1. Find h of negative 4. So h of negative 4, we're putting in a negative 4 wherever there's a t. You've got to use parentheses. So instead of a t, there's a negative 4 squared plus 1. So now negative 4 squared is negative 4 times negative 4, which is positive 16. 16 plus 1 is 17. So our function h at negative 4 was 17. Once again, when we plugged in negative 4, we got out 17. Everybody understand? You good? Okay, so now this is different. So this is subtraction, subtracting a polynomial. So we have this polynomial, subtract this polynomial. So we've done some of this in the past. I call subtraction a red flag problem because a lot of people miss subtraction for this one reason. They forget to distribute the negatives. So let's write a negative 1, and then I'm almost done and I'll be right with you. So negative 1 times k squared is negative 1k squared, right, everybody? And then this is where people miss it. Negative 1 has to be distributed over to this term as well. So negative 1 times positive 4k is negative 4k. Does everybody understand where I got that from? Now, there was not a negative in front of these two terms, so we just get to drop them down exactly as they are. They didn't change. We didn't have a negative in front. And now we're just going to combine like terms. So like terms, what's x? Let's do an easier one. What's x plus x? How many x's do we have? How many apples? 2 x's, 2 apples. An apple plus an apple is 2 apples. So let's start with our highest degree. We have 3k to the third. Do we have any other k to the thirds? So no other apples to add with this apple. So we have 3k to the third. Now I'm going to cross that one out so I don't miss anything. 4k squared minus 1k squared is how many k squareds? 3k squareds, positive 3k squareds. Very good. So we've done those. And then last, minus 4k. Now, once again, we can't combine. This is an apple, an orange, and an apricot, right? We can't combine those. Is everybody good with that? Okay, awesome. So what I'm going to have you do is start working on the worksheet, and then we'll do just a couple more in just a second. Only 2 more examples. So once again, you have to say to yourself, what am I doing with these polynomials? But see how they're right next to each other? This is multiplication. So this one has 2 terms, this one has 2 terms. So basically what we're doing is we've got to multiply both of these to both of these. So we've got to draw in this as we go. So double distribute, some teachers call it FOIL. Front, I don't even know what FOIL, I don't ever teach FOIL, because it's like, I just teach the double distribute. So let's start here. 3n, let's start with this term. 3n times 8n is positive 24. Now n times n, guys, is n squared. Everybody good with that? Now you have to multiply 3n to negative 1. So 3n times negative 1 is negative 3n's. So now I've distributed 3n to both terms. Now we'll move on. We've got to take this term right here, positive 8, and distribute it through to both. So positive 8 times positive 8n is positive 64n. Everybody good? Then positive 8 times negative 1 is negative 8. Now we'll combine like terms. Now notice we could always multiply things that are different, like 3n times negative 1. You can always multiply things that are different. You just can't add and subtract things that are different degrees. Does that make sense, everybody? So let's combine like terms. 24n squared, there is no other n squared. So we still have 24n squared. Negative 3n plus 64n's is positive 61n's. 64 minus 3. Does that make sense, everybody? 64 apples minus 3 apples is 61 apples. The apple part doesn't change. And then minus 8. Now it's in standard form, which means highest degree to lowest degree. So we're done. This is the opposite of factoring, guys. If we took this quadratic and factored it, we'd end back up at the linear factors. Does everybody see how this is just the opposite? We multiplied it out. Okay, so looking at 19, this will be the last one I do. You'd say to yourself, what am I doing here? It's this polynomial times this polynomial. So remember that we've got to be really careful here. We've got to multiply this to both of those. So 2n to the 4th times positive 4n. Multiplication, you can multiply different things. You'll just use properties of exponents. I'm going to remind you of something. This is n to the 1st power. So what's 2 times 4? 8. Then we have an n to the 4th times n. When you multiply the same base, you add your exponents. 4 plus 1 is 5, correct? So we have n to the 5th. Now we have to do 2n to the 4th times positive 4. 2 times 4 again is positive 8. And then we have our n to the 4th still. Now once again, you have to ask yourself, can I add these together? No, this is an n to the 5th, this is an n to the 4th, this is an apple, this is an orange. We cannot combine those, so we're done. So don't do weird things and start adding them and add, you know what I mean? Okay, awesome. So hopefully that's enough to let you finish that worksheet. When you're done with that, we'll give you back your test and have you start doing some test corrections. But I have to have you check off all of those with me and then see how